Okay, so this is the XDK. XDK code can be shared very simply by opening an Intel XDK project and then navigating to an XDK file. The XDK file, alongside all the other code, will be shared on the GitHub. I've already imported the code in this case. Okay, let's take a look at the actual code. Here we are importing the AWS IoT Device SDK, a module which we will use to connect to AWS IoT. We have to specify the certificate paths, and we're using the certificates generated by the connection package we pushed to the board earlier. We also have to specify a host, and in this case we're using the endpoint of our AWS IoT device. You'll have to specify your own specific endpoint. You can find your endpoint by navigating to the AWS IoT device dashboard. Further on, we can see different cases for when the connection first connects, disconnects, reconnects, and receives a new message. When the connection receives a new message, it will update the local device state based off of the payload of the message. Since the payload is a JSON object, it's really simple to parse out the states for the green and the red LEDs. I have set the green and the red LEDs by assigning them to a specific pin into which I plugged in the green and then the red LED. Once the local state is updated, we want the gateway to actually turn on and off the LEDs attached to the Arduino 101. As I mentioned earlier, the Arduino 101 is communicating to the gateway using the Fermata protocol. Now, the Fermata protocol is a standard part of the MRAW library. The MRAW library is created and maintained by Intel for interfacing with GPIOs on various boards and gateways. MRAW is a low-level library, which takes care of reading digital signals, analog voltages, or interfacing with I2C buses and the like. On top of MRAW is the UPM, or Useful Packages and Modules library, which is a high-level sensor library. This library currently supports 300 sensors and is currently growing. Another really cool thing about the XDK is that you're able to access the entire library right from the IDE. You can find the sensor you want to use, import the module, see the API description, and even get some sample code. For this project, we will only be using the low-level MRAW library, since all we want to do is turn on a couple of pins to high or low. And we can do that by using the write method here. Once we're done writing the code, we will want to connect to the board. We can do so by connecting to our gateway IP here. Once connected, we can upload the code and then hit run. As we can see from the output, the gateway is now connected to AWS IoT and is ready to start getting commands from our custom skill.